In terms of improved control techniques, modified PWM control techniques, DC bus voltage control, current control based techniques, direct torque control, and phase. Now, this is mainly, I would say, related to BLDC, where you have trapezoidal control, where you can improve the trapezoidal control by using some of these techniques. Okay. So let's look at short circuit conditions at motor terminals, what happens and how can we detect them. And then we also look at internal, external power supply voltages and over temperature failure conditions that we need to have in the drive as a standard protection mechanism. Okay. So we're looking at a short circuit to ground, short circuit to battery, short circuit to line, weak short circuit in the microcontroller, Hall problem, and then MOSFET issues, right? Those are some of the issues we're going to discuss here. So in terms of, we can have on-state monitoring or off-state monitoring in terms of the issues we deal with in the motors. So let's look at this short circuit to ground. So when you have a short circuit to ground, so what you see here is you have a microcontroller section here, and then you have a hot bridge here. You have a battery on the top, and then you have a ground here, and you have a sensor resistor here. So with this, if you have a short circuit here to ground, essentially you have a shorted current being flowing, you're bypassing this resistor here, right? So you can, so one way is to monitor the drain to source voltage of this top MOSFET. And by monitoring the drain to source voltage, you know that the short circuit current is going to be V battery divided by the RDS on of this MOSFET. Okay. So if that short circuit current is greater than that value, you can set a threshold. You can set what is your arbitrary threshold between the drain to source voltage. You can say maybe it is 2 volts, maybe it is 3 volts. Whatever it is, because your battery is going to short to here. So I guess you're still controlling, let me see here, VDS threshold. So you can set your threshold across this drain to source voltage. And you can see here, you have a VDS monitoring here. And this VDS monitoring with the reference level, the threshold, you can trigger a fault. Okay, so you can basically say, okay, that it's too much of a short circuit current. I need to shut down my inverter. Then this will require some kind of a calibration based on temperature. So here you can see what happens to the short circuit current based on various temperatures. The short circuit current goes down and the resistance goes up. And you have a short circuit maximum value, minimum value, and typical value. So with this curve, you can set what your level should be in terms of triggering your microcontroller to shut it down.